So an object relational mapper, or ORM, is a layer of software that's used by software developers in their applications to bridge the fundamental difference between an application that's developed using object-oriented design principles and the database that was developed using relational database design principles like normalization. Now, the fact is that for the most part, most of the time, those two worlds share more similarities than differences. A class has properties in a similar way that a table has columns. Both properties and columns have a data type, although it's likely to be a different set of data types available to each of those, the language versus the database. You can generally represent relationships between classes using a property that has a reference to another instance of a class, a different class. And you'd represent relationships between tables using a primary key, foreign key relationship. So the ORMs most of the time are just simply trying to smooth out the differences in the way that each of these paradigms work. Now, typically, they also allow the developer to query or perform CRUD operations using an API rather than switching modalities to use a different language, a context switch to SQL, rather than the programming language that they've been working with up to this point, which for you is presumably C#, but it could be any programming language. Now, in more advanced scenarios, an ORM may be used to fundamentally provide a different way of representing data. And you can see a little illustration here. It's just, I quickly put this together. On the left-hand side, perhaps an application is modeled in such a way that a customer has a home phone and a work phone property on the customer class itself. Whereas in the database, the DBA or the designer went through normalization and determined that there's a customer table and a phone table. And so you would have a phone type that would distinguish not just home and work phone, but perhaps you'd have cell phone and various other kinds of alternate phones, pager, fax, whatever the case might be. And then they would be tied together with a primary key, foreign key relationship on customer ID. Now, you can see the challenge here. In order to get the data from the right-hand side into the left-hand side, there's got to be some custom code that's written that maps, that first of all searches for just those phone types that match home phone and work phone, and then maps those actual phone numbers to instances of the customer object's home phone property and work phone property. Just imagine how much effort that would be. Well, ORMs give you some mapping capability to do this sort of thing in advanced scenarios. At least some of them do. I know there's an advanced ORM that's been around for a long time in the .NET world called LLBLGen, and I think you can do this sort of thing with it. But the worst case scenario is that you have to write some custom code. In most cases, however, in most greenfield software development projects, you can usually dictate both the class model and the database model. And so you can rely on out-of-the-box tooling and utilities to handle that mapping, especially if you're flexible on both sides of the coin. Now, the entity framework works best when you can dictate either the shape of the database model or the class model, or ideally both. In those scenarios where you don't have the flexibility to change the database model, at least you can reverse engineer it to create the entity model inside your application. But in a nutshell, that's what a object relational mapper is and how it works for you.